Tonight, we are going to talk about the planet that looks almost like Earth's twin, but would destroy you before your feet ever touched the ground. From far away, Venus does not look like a nightmare. It is close to Earth in size, it shines beautifully in our sky, and for a long time, people imagined that beneath its thick clouds there might be oceans, forests, or even a warmer version of our own world. But the closer you get to Venus, the more that illusion falls apart. The clouds are not peaceful. They are filled with acid. The atmosphere is not breathable. It is thick, toxic, and crushing. And the surface is not just hot, it is hot enough to melt lead. A journey to Venus would not feel like landing on another Earth. It would feel like descending into a planet that punishes you more with every kilometer, until the sky, the pressure, and the heat all become impossible to survive. So tonight, the question is simple. Why would Venus kill you before you even land? Before we begin tonight's journey, subscribe to the channel if you want more calm space documentaries like this. Leave a like if you enjoy deep space mysteries, and write in the comments where you are watching from and what time it is where you are right now. Tonight, you are watching the Just About Space channel, talking about why Venus would kill you before you even land. The answer begins with the first illusion Venus gives us. From a distance, it does not look like a dead world. It does not look like a planet that would crush machines, melt metal, and destroy anything human long before a safe landing could happen. In the sky above Earth, Venus can look gentle. It shines with a calm white brightness, sometimes appearing before sunrise, sometimes after sunset, bright enough to catch the attention of people who may not even know they are looking at another planet. For thousands of years, Venus was not a symbol of death. It was a beautiful light. That is part of what makes it so dangerous in the imagination. Some places in space look terrifying immediately. Jupiter looks enormous. Saturn looks alien. Neptune looks cold and distant. Mars looks dry and hostile. But Venus does not begin that way. Venus begins by looking familiar, close, and almost friendly. It is one of the brightest objects in Earth's sky, because it is nearby, because it is covered in reflective clouds, and because it orbits closer to the Sun than Earth does. To the human eye, it is not a monster. It is a shining point, soft and steady, often mistaken for a star. It appears so peaceful that it can feel impossible to connect that light with the nightmare hidden underneath. This is the first strange truth about Venus. The planet that looks beautiful from Earth is one of the most hostile places in the solar system. And the reason it fooled us for so long is that, on paper, Venus seems almost like a second Earth. It is close to Earth in size. It is close to Earth in mass. It is a rocky planet, not a gas giant. It has a solid surface somewhere below its clouds. It lives in the inner solar system, not in the frozen darkness beyond Neptune. It is not a tiny asteroid, not an icy moon, not a distant dwarf planet. It is a large, rocky world, orbiting the same sun as us, not extremely far from our own planet. So before we knew what was under the clouds, it was easy to imagine possibilities. Maybe Venus was warm. Maybe it had oceans. Maybe it had continents. Maybe beneath the clouds there was a thick, wet, tropical world. Maybe it was not a hell, but a hidden version of Earth. That was the trap. Venus did not look like a warning at first. It looked like a promise. When people call Venus Earth's twin, they usually mean the similarities that appear from far away. The two worlds are close in size. Both are rocky. Both formed in the inner solar system. Both orbit the Sun within a region where rocky planets developed from ancient dust, metal, and stone. If you only compare the basic numbers, Venus seems less like an alien nightmare and more like a nearby sibling. But siblings can grow into completely different lives. Earth became blue, wet, and alive. Venus became sealed under clouds, crushed by atmosphere, and burned by a runaway world of heat. The terrifying part is not that Venus is different from Earth. The terrifying part is that it is similar enough to make the difference meaningful. If Venus were a gas giant, we would not compare it to our home. If it were a frozen ice world at the edge of the solar system, we would not feel the same discomfort. But Venus is close enough to Earth's category that its destruction feels personal. It is a rocky planet that went wrong, a familiar type of world pushed into a completely hostile state. That is why Venus is not just dangerous. It is disturbing. It shows that being Earth-sized does not mean being Earth-like. A planet can have the right kind of body and still become impossible for life as we know it. It can be rocky, bright, nearby, and beautiful, while hiding a surface more lethal than almost anything we can imagine. Venus reminds us that a planet's appearance from space can be one of the worst ways to judge it, because Venus hides itself. Unlike Mars, whose surface can be seen through telescopes as a reddish world with visible markings and polar caps, Venus keeps its face covered. Its thick cloud layer wraps the entire planet, reflecting sunlight and blocking the view beneath. From outside, you do not see continents. You do not see oceans. You do not see mountains or plains. You see a brilliant, cloud-covered sphere, a mask, a planet wearing a veil. That veil made Venus mysterious for a very long time. It allowed imagination to fill in what observation could not. If you cannot see the surface, you can dream about what might be there. And for a long time, people did. The clouds suggested moisture. The brightness suggested beauty. The location near Earth suggested familiarity. So the hidden world below became a place where fantasy could survive. Maybe Venus was not hostile. Maybe it was only hidden. But the truth was waiting beneath the clouds. And it was worse than almost anyone expected. The first lesson of Venus is that distance can make a deadly world look harmless. From Earth, the planet is silent. It does not reveal its pressure. It does not show its heat. It does not show its toxic sky. It does not show the way machines struggle to survive there. It simply shines. That beautiful light is sunlight reflected from a world that would destroy you. The same clouds that make Venus bright are part of the reason it is terrifying. They hide the surface. They trap heat. They belong to an atmosphere that is nothing like the air around Earth. So even before we begin descending, before we imagine a spacecraft entering the sky, before we talk about pressure or heat, we have to understand the deception. Venus looks like a candidate for a second Earth because it gives us the right first impression. It is rocky, it is close, it is bright, it is nearly our size. It is wrapped in clouds. But every one of those details becomes darker when we look closer. The closeness does not make it safe. The clouds do not make it gentle. The brightness does not mean life. The similarity does not mean survival. This is why Venus is such a powerful subject for a journey. It begins with hope and ends with punishment. It begins as a twin and becomes a warning. It begins as a shining object in the evening sky and becomes a place where a human body could not last, where ordinary spacecraft would need extraordinary protection, and where the environment attacks from every direction. Venus is not dangerous in just one way. It is dangerous as a whole planet. The atmosphere is the first wall. It is mostly carbon dioxide, thick and heavy, nothing like the mixture of gases we breathe on Earth. A human being could not step out into it. There is no breathable air waiting beneath the clouds. There is no gentle surface wind carrying oxygen. There is no open sky where a person could remove a helmet and survive even for a moment. But the lack of oxygen is only the beginning. On many worlds, no breathable air would already be fatal. Mars, for example, is dangerous because its atmosphere is thin and cold, and humans would need protection immediately. But Venus is not simply a world without breathable air. Venus is a world where the atmosphere itself becomes a weapon. It is thick enough, hot enough, and chemically hostile enough to turn the idea of a landing into a descent through layers of danger. That is what makes the title true. Venus would begin killing you before you ever reach the ground. The danger does not wait politely at the surface. It begins above it, in the clouds, in the chemistry, in the heat, and in the growing pressure. As you fall lower, a journey to Venus would not be like landing on a dry desert planet. It would be like descending into a sealed furnace wrapped in acid clouds and compressed atmosphere. And yet, from Earth, it is beautiful. That contrast is the heart of Venus. A shining planet hiding a planetary trap. This is why Venus can feel more unsettling than a world that is obviously alien. A gas giant is terrifying because it is nothing like Earth. Venus is terrifying because it almost invites the comparison, then destroys it. It says, "Here is another rocky planet near the sun. Here is another world about Earth's size. Here is another bright object in your sky." And then beneath the clouds, it reveals a place where Earth-like expectations fail completely. It is the solar system's false twin. A world that looks familiar only until you understand it. When we imagine a human mission to Venus, the first mistake would be thinking of the surface as the main challenge. In reality, the whole descent would be dangerous. Long before a lander touched the ground, it would have to pass through a thick atmosphere that grows more extreme with every kilometer. Every lower layer would bring higher pressure and greater heat. The planet would not suddenly become deadly at the end. It would become deadly gradually, relentlessly, and without mercy. The approach might begin quietly. From space, Venus could look smooth and bright, almost peaceful. A glowing sphere covered in clouds, no craters visible, no sharp continents, no obvious storms tearing across the surface, just a brilliant planet wrapped in light. But that smoothness is not safety. It is concealment. As a spacecraft moved closer, the details would still be hidden. The clouds would dominate everything. There would be no clear landing site visible to the eye. No blue ocean. No green land. No familiar surface features. The planet would not welcome you with a view. It would keep its secrets until the descent began. That is when the illusion would break. The upper atmosphere would be the first layer of reality. The spacecraft would meet a world with air far thicker and stranger than Earth's. Instruments would begin reading conditions that do not belong to a human world. The clouds would not be soft white water vapor like Earth's clouds. They would be part of a chemically hostile atmosphere, one that reflects sunlight beautifully while hiding danger below. This is the second lesson of Venus. Beauty is not the same as habitability. A planet can shine because it is covered in clouds, and those clouds can still be deadly. A world can look calm because its surface is hidden, and the hidden surface can still be unbearable. The universe is not required to make dangerous places look dangerous from far away. Venus proves that. It gives us a beautiful warning. This makes Venus one of the best reminders that habitability is fragile. Earth is not comfortable simply because it is rocky and near the sun. Earth is comfortable because many things are balanced in a rare and complex way. Its atmosphere is breathable. Its pressure is mild. Its temperature allows liquid water. Its clouds do not hide a global furnace. Its surface can support oceans and life. Venus shows how a similar rocky world can become something else entirely. Not a second home, a warning next door. Because Venus tells us that a planet can start with similarities and end with disaster. It makes Earth feel less inevitable. The comfort of our world becomes more mysterious when Venus is beside it. Why did Earth keep its oceans? Why did Earth remain temperate enough for life? Why did our atmosphere become breathable while Venus became suffocating and dense? Why did one rocky world become home while the other became a furnace under clouds? Those questions are larger than the first chapter, but they begin here. They begin with the fact that Venus looks like Earth only from far away. The closer we get, the more the twin becomes a stranger. This is why the first stage of the journey must be about appearance. Before we descend into acid clouds, crushing pressure and metal-melting heat, we have to understand why Venus was ever tempting. A nightmare that looks like a nightmare is easy to fear. A nightmare that looks like a bright sister world is more dangerous to the imagination. Venus fooled us because it had the shape of possibility. A hidden surface, a thick atmosphere, a bright face, a size close to Earth, a place near enough to dream about. But the dream depended on ignorance. Once instruments began to reveal the truth, the gentle image collapsed. The clouds were not a curtain hiding paradise. They were part of the prison. The atmosphere was not a sign of comfort. It was a crushing, toxic blanket. The heat was not mild warmth. It was planetary punishment. The planet that looked almost familiar became almost impossible. And that is where the descent truly begins. Because once we accept that Venus only looks like Earth from far away, the next question becomes even more unsettling. How did it fool us for so long? What did people imagine was waiting under those clouds? And how did one of the brightest, most beautiful objects in our sky turn out to be one of the most lethal worlds ever explored? The answer is that Venus was not only hidden from view, it was hidden in the right way. A planet covered in clouds does not automatically look terrifying. On Earth, clouds are connected with rain, weather, water, storms, oceans, and life. When people looked at Venus and saw a world completely wrapped in cloud, it was natural to imagine something wet beneath them. Maybe a warm ocean world, maybe endless rain, maybe tropical forests, maybe a planet where thick clouds protected a humid surface from the sun. The clouds did not look like a prison at first. They looked like a curtain. And behind a curtain, the mind can build anything. That was the problem with Venus. It gave scientists and dreamers just enough information to be tempting, but not enough to reveal the truth. They knew it was a planet. They knew it was close. They knew it was similar in size to Earth. They knew it was bright. They knew it had an atmosphere. But the surface remained invisible. That invisibility allowed hope to survive. When Mars was studied, people could at least see a reddish surface. They could see markings, polar regions, and changes through telescopes, even if many early interpretations were wrong. Mars looked dry, exposed, and strange. But Venus refused to show itself. It offered no open landscape, no clear mountains, no oceans, no continents, no direct clues from the surface. Only clouds, a smooth, shining mask. And because the mask was bright, people could imagine beauty behind it. For a long time, Venus existed in a strange space between science and imagination. It was real enough to measure, but hidden enough to dream about. Writers imagined jungles. Some imagined oceans. Some imagined strange life under the clouds. Even serious speculation could lean toward the idea of a hot, wet world, because the available information did not yet prove the opposite clearly enough. From far away, Venus seemed like the kind of place where something might be hiding. And hidden worlds are powerful. They invite stories. The idea of a Venus covered in steaming jungles was not random. It came from a chain of assumptions that felt reasonable at the time. Venus is closer to the sun than Earth, so it might be warmer. It is covered in clouds, so maybe there is a lot of water. It is similar in size to Earth, so maybe it holds an atmosphere like Earth. If Earth has clouds, oceans, and life, maybe Venus has the same things in a hotter form. The logic was wrong, but it was understandable. The danger was that Venus looked like a familiar problem, a cloudy planet waiting to be revealed. It did not yet look like a completely different kind of nightmare. Before spacecraft and radar changed the story, the thick atmosphere was not fully understood. The surface temperature was not known in the way it is today. The pressure was not something people could easily imagine. The clouds seemed mysterious, not necessarily lethal. The unknown became a place where Earth-like expectations could survive. This is how Venus became one of the great false hopes of the solar system. It was close enough to feel reachable, large enough to feel important, cloudy enough to feel wet, bright enough to feel beautiful, and hidden enough to let the imagination protect it from reality. But reality was waiting. The more scientists learned, the more the gentle version of Venus began to collapse. The clouds were not simple water clouds like those above Earth. The atmosphere was not mild. The surface was not a tropical paradise. There was no easy view downward because the planet was buried beneath a thick, hostile envelope. Instead of hiding oceans, the clouds were hiding an inferno. That reversal is what makes Venus so dramatic. The same evidence that once made the planet feel promising became evidence of danger once understood correctly. The thick clouds did not mean comfort. They meant a massive atmosphere. The brightness did not mean freshness. It meant a reflective shroud. The closeness to the sun did not mean pleasant warmth. It helped drive a brutal planetary greenhouse. Venus did not become terrifying because it changed. It became terrifying because our understanding changed. The planet had always been that way. We were the ones seeing it incorrectly. That is a powerful theme in astronomy. The universe often does not match the first story our eyes tell. Earth seems still, but moves. The stars seem fixed, but travel. The Milky Way seems like a band, but is a galaxy. Venus seems gentle, but is a furnace. In each case, appearance gives a simple answer, and deeper observation destroys it. Venus is one of the clearest examples because the correction is so extreme. From possible paradise to planetary hell. From Earth's twin to Earth's warning. From bright evening star to lethal world. The question is not just why Venus fooled people. It is why the mistake felt so plausible. The answer lies in how much Venus resembles Earth from a distance and how completely it hides the details that matter. Habitability is not decided by size alone. It is not decided by having clouds alone. It is not decided by being rocky alone. It depends on temperature, pressure, chemistry, atmosphere, water, and history. Imagine looking at Venus before the truth was known. You see a brilliant planet in the twilight. It has no visible scars from your viewpoint. It has no obvious frozen surface. It does not look like a dead rock. It does not look like a gas giant with no ground. It is close, bright, cloud-covered, and almost the same size as Earth. If you wanted to believe there was another world nearby, Venus gave you permission. But permission from distance is not proof. The clouds were hiding the answer, and the clouds were also part of the answer. That is the cruel symmetry of Venus. The thing that made it mysterious was not separate from the thing that made it deadly. The cloud cover was not simply blocking our view of the danger below. It belonged to the deadly system. It reflected sunlight, trapped heat, and sat inside an atmosphere far denser than Earth's. The mask was part of the monster, a veil made of the same world it concealed. This is why the dream of Venus had to end slowly. No telescope could simply look through the clouds and settle the question. Visible light could not reveal the surface. The planet kept its secrets until better techniques and spacecraft arrived. Radar had to map what eyes could not see. Probes had to enter the atmosphere. Instruments had to measure the reality directly. Only then did the hidden planet become clearer. And what emerged was not a paradise. It was a pressure cooker, a furnace, a toxic world wrapped in acid clouds. The change in understanding was brutal. A planet once imagined as warm and wet became a place where the surface pressure is crushing. The atmosphere is mostly carbon dioxide, and the temperature is hotter than the surface of Mercury in many ways, despite Mercury being closer to the Sun. That is one of the most shocking facts about Venus. Distance from the Sun is not the whole story. Atmosphere can change everything. The planet closest to the Sun is not the hottest, in the same way Venus is. Venus became hotter because its atmosphere traps heat with terrifying efficiency. This is where the idea of the greenhouse effect becomes central. On Earth, a greenhouse effect helps keep the planet warm enough for life. It is not automatically bad. Without some heat-trapping gases, Earth would be far colder. But Venus shows what happens when the balance becomes extreme. Its thick carbon dioxide atmosphere traps heat so powerfully that the surface becomes unbearably hot. The same broad physical idea that helps Earth stay habitable becomes catastrophic on Venus. That is why Venus feels like a distorted mirror. It is not simply alien. It is familiar physics pushed into a deadly direction. This contrast is important because it makes Venus unique. Many people imagine space danger as emptiness. No air, cold, radiation, vacuum. Venus is dangerous for almost the reverse reason. It has too much atmosphere, too much pressure, too much chemical hostility. It is not the absence of a world. It is the excess of one. A planet that smothers rather than freezes. A sky that crushes rather than disappears. This is why Venus would kill you before landing. The danger is not just on the ground waiting like a trapdoor. It begins in the sky. The atmosphere itself is part of the descent. The clouds are not decorative. The air is not empty space. Every kilometer downward would take you deeper into a system designed by physics to become worse. The old dream imagined clouds as soft. The real descent reveals them as warning signs. At first, high above Venus, you might still feel the illusion. The planet would look bright and smooth beneath you. Sunlight would pour across a pale cloud deck. There would be no visible lava lakes, no exposed deserts, no mountains screaming danger from orbit. Just a world hidden under yellow-white brightness. But as instruments studied the planet, the dream would collapse again. The atmosphere would reveal its chemistry. The heat would rise. The pressure would increase. The clouds would become less like weather and more like a barrier between imagination and reality. This is the transition from appearance to environment. A planet is not just its surface. It is everything you must pass through to reach the surface. On Venus, that means the sky itself is part of the threat. This was the mistake in early imagination, thinking of the clouds as something above the real world, like Earth's clouds floating over oceans and land. But on Venus, the clouds are part of a planetary system so extreme that there is no safe, normal world below them. The further down you go, the more the atmosphere becomes the planet's weapon. The clouds do not hide Earth's twin. They hide the place where the twin died. That is the emotional core of this chapter. Venus fooled people because it offered the outer shape of Earth without the inner conditions that make Earth livable. It had enough similarity to invite hope and enough secrecy to protect that hope. But once the secrecy ended, the hope did not survive. The planet underneath was not waiting to be discovered like a home. It was waiting like a warning. And warnings are often more valuable than fantasies. It is not a random monster at the edge of space. It is nearby. It is bright. It is almost our size. And it shows that a planet can become unlivable in a way that is not obvious from its face. This is why the story of Venus must begin with being fooled. Before we can understand why it kills, we have to understand why it looked like it might not. The shock comes from the gap between expectation and truth. If Venus had always looked like a burned, exposed, cracked world, the emotional effect would be weaker. But because it shines beautifully and hides its surface, the truth feels like a betrayal. Venus looks like a promise, then reveals itself as a trap. The next part of the journey takes us directly toward that trap. We have understood why the planet could be mistaken for a second Earth. We have seen how the clouds allowed imagination to survive. But now we have to move closer to those clouds themselves. Because the cloud layer is where the beautiful mask becomes physical. It is the first thing a spacecraft would meet. It is the reason the surface stayed hidden for so long. And it is the beginning of the descent into a planet that becomes more deadly with every layer below. The first layer is the cloud cover. From far away, the clouds of Venus look smooth, bright, and almost calm. They turn the entire planet into a shining sphere, reflecting sunlight so strongly that Venus becomes one of the most brilliant objects in Earth's sky. To the eye, there is no exposed desert, no visible lava plain, no cracked surface, no dark ocean, no sign of crushing pressure or impossible heat. There is only brightness. But that brightness is a disguise. Venus is not bright because it is gentle. It is bright because its atmosphere is wrapped in thick reflective clouds that hide almost everything underneath. The cloud deck is so complete that the planet does not show its true face in visible light. Earth reveals itself from space with blue oceans, white clouds, brown deserts, green land, and changing weather. Mars reveals its rust-colored plains and polar caps. The Moon shows its craters, but Venus shows almost nothing of its ground. It hides. That hiding is one of the reasons Venus feels so unsettling. A dangerous world that shows its danger can be understood immediately. But Venus does not show the danger directly. It covers it in light. It appears smooth and beautiful, while the real planet waits below, sealed away under an atmosphere so thick that ordinary vision cannot reach the surface. If you were approaching Venus in a spacecraft, the planet would not open itself to you like Earth does. Earth from space is full of detail. You can see weather systems, coastlines, continents, storms, ice, and oceans. You can immediately understand that there is a surface below the atmosphere. Venus would be different. As you moved closer, the clouds would continue to dominate the view. You would see a glowing, pale world with no obvious place to land. No coastline, no mountain range, no dark valley, no welcoming horizon, just a planet-sized cloud wall. That is the first problem with landing on Venus. Before the heat and pressure destroy the fantasy completely, the planet refuses to even show you where you are going. The surface is not visible in the familiar way. A mission cannot simply look down through clear air and choose a landing zone by sight. The planet's face has to be discovered with instruments, especially radar, because radar can pierce the cloud cover and reveal the hidden terrain below. This means Venus had to be mapped like a secret, not by ordinary vision, but by seeing through the mask. That alone makes the planet feel different from Earth. On our world, clouds move and break. They reveal the ground. They change hour by hour. They are part of a living atmosphere, but they do not permanently erase the planet beneath them. On Venus, the cloud cover feels more like a closed lid. It does not give the same sense of openness. It wraps the planet so completely that the surface becomes a hidden prisoner. For a human imagination, clouds usually mean sky. On Venus, clouds mean concealment, and concealment is the beginning of danger. The cloud layer changes the emotional experience of a descent. A spacecraft entering Earth's atmosphere can pass through clouds and emerge into a view of land or ocean. A plane can fly above clouds and then descend towards cities, fields, rivers, and runways. Clouds may block the view for a while, but they do not usually feel like the boundary between one world and a nightmare. On Venus, they would. Above the clouds, Venus might still look beautiful. Below them, the environment would begin to reveal itself as something far more hostile. A descent would feel less like landing and more like crossing a barrier. The clouds are not just decoration around the planet. They are the first visible part of a system that has trapped the surface in extreme conditions. The deeper you go, the more the illusion fails. This is why the phrase cloud-covered planet can be misleading. On Earth, A cloud-covered sky can feel peaceful or familiar. On Venus, the same phrase points to something darker. The clouds are part of an atmosphere that hides, heats, and traps. They do not float above a comfortable world. They belong to a world that has become sealed off from anything Earth-like. The clouds of Venus are not soft in the way we imagine clouds from the ground. They are the top of a planetary envelope, a visible surface above an invisible surface. When we look at Venus, we are not seeing the ground of the planet. We are seeing the upper layers of its atmosphere. That means the bright object in our sky is not really the surface of Venus at all. It is the shine of the planet's cloud tops. The world itself is buried beneath them. That single fact changes everything. The Venus people once imagined was based on an unseen surface. The real Venus had to be uncovered indirectly. Spacecraft and radar showed that beneath the clouds there are plains, highlands, volcanoes, impact features, and strange landscapes. But even knowing that does not make the surface accessible. A map is not the same as a safe world. A place can be mapped and still be deadly. Venus proves that exploration does not always mean approachability. We can know a planet and still not be able to survive it. The cloud cover also creates a psychological problem for any human mission. People like to see where they are going. Pilots, astronauts, explorers, and travelers depend on visibility. Even when instruments guide the way, the human mind wants a horizon, a landmark, a sense of place. Venus denies that at first. It gives no simple visual promise. You descend into brightness, then haze, then thickness, with the surface still hidden until the world around you becomes more dangerous. It is a planet that makes you trust instruments before it lets you see. And by the time you are deep enough to understand the environment, escape would already be extremely difficult. This is why Venus would not feel like a normal landing. It would feel like entering a trap that was beautiful from outside. A spacecraft would not simply descend through blue sky. It would pass into layers of atmosphere that grow heavier and more hostile. The sky would not become clearer in a comforting way. It would become stranger, yellower, thicker, more oppressive. The clouds mark the beginning of that transformation. Above them, Venus is an object in space. Inside them, Venus becomes an environment. And that environment is the enemy. The cloud cover is also connected to the runaway heat of the planet. Venus receives sunlight, reflects a large portion of it, and still ends up with a surface hotter than any world with a solid surface should feel from Earth's point of view. The atmosphere traps heat with brutal efficiency. The clouds help shape the planet's energy balance, while the dense carbon dioxide atmosphere below turns Venus into a furnace. The surface is hidden from view, but it is not protected in the way Earth's surface is protected. The clouds are not cooling Venus into habitability. They are part of a system that keeps the surface locked away in heat. This is a strange contrast. From space, reflective clouds make Venus look bright and clean, but underneath, the planet is suffocating. A bright outer layer can hide a darker inner reality. It is almost the perfect symbol of Venus itself. Beautiful light above, deadly pressure and heat below. That is why the cloud layer is more than a visual detail. It is the planet's first lie. It says, maybe this world is soft. Maybe there is water. Maybe there is a surface like Earth. Maybe there is something familiar below. But the descent answers differently. There is no blue sky waiting, no ocean waiting, no breathable wind, no gentle ground. Only a deeper atmosphere, stranger chemistry, rising pressure, and heat that will keep increasing as the surface approaches. The clouds are the doorway into all of that. For robotic spacecraft, this doorway has always been one of the first challenges. A probe entering Venus cannot rely on the same expectations as a spacecraft landing on Mars. Mars has its own difficulties: thin air, cold temperatures, dust, and radiation. But its surface can be seen. Its sky is thin, A lander can photograph the approach and recognize the ground. Venus is more secretive. It hides the ground and forces the machine to descend through a thick, hostile atmosphere. The lander does not simply land on Venus. It enters Venus. That wording matters. Venus is not just a surface with some air above it. The atmosphere is so dominant that the descent itself becomes part of the planet's danger. A mission would begin dying, struggling, heating and resisting before it ever touched the ground. The surface is the final stage, not the beginning of the threat. This is why a human mission to the surface is so nightmarish. On many worlds, the problem is reaching the surface and then surviving there. On Venus, the problem begins during the approach. The spacecraft must survive entry, clouds, chemistry, heat, pressure, and the growing violence of the lower atmosphere. The planet does not save its worst conditions for a dramatic final moment. It increases them steadily. A descent into Venus is a descent into worsening reality. Layer by layer, the dream disappears. First, the beautiful planet becomes a hidden planet. Then the hidden planet becomes a chemically hostile planet. Then the atmosphere becomes thicker. Then the pressure becomes crushing. Then the heat becomes impossible. The clouds are only the first step, but they are the step that tells you the world is not honest from a distance. They are the reason Venus could be imagined incorrectly. They are also the reason the truth feels so sudden when revealed. If the surface were visible from Earth, the fantasy might have died earlier. We might have seen a barren, hostile landscape and understood sooner that Venus was no second Earth. But the clouds preserved mystery. They allowed the planet to remain a blank canvas for too long. And because people naturally filled that blank canvas with Earth-like ideas, Venus became a world of false hope. The clouds gave imagination a place to hide. Then, science took that hiding place away. Radar mapping and spacecraft measurements did not simply add facts. They shattered a dream. They turned the cloud-covered world from a possible paradise into a lesson about planetary danger. They showed that beneath the bright cover was not a warm ocean world, but a landscape under unbearable heat and pressure. The mask remained beautiful. The face beneath it was deadly. This is why Venus can be compared to a locked door. From outside, the door may look clean, bright, and calm. But what matters is not the door's appearance. What matters is what waits behind it. The clouds are the locked door of Venus. They protect the illusion until instruments force it open. And once it opens, the planet changes completely. But even before reaching the lower atmosphere, the clouds themselves deserve attention. They are not Earth-like clouds made mainly of water droplets. They are associated with sulfuric acid droplets, part of a harsh chemical environment that would be dangerous to materials, machines, and humans. That means the first visible layer of Venus is already hostile in a way Earth's clouds are not. This is where the next chapter of danger begins. The clouds do not just hide, they attack. From the outside, they make Venus shine. From within, they become part of an acid sky. A spacecraft descending through them would not be passing through a harmless mist. It would be entering a corrosive chemical environment. One more reason Venus would begin destroying an unprotected mission long before the surface. This is the moment the beautiful mask becomes physical danger. The cloud deck is no longer just a mystery. It becomes a substance, a place, a hazard, a layer of the planet that any descent must survive. For a human being, this is almost impossible to imagine, because our experience of clouds is gentle by comparison. Clouds on Earth can bring storms, lightning, rain, and danger, but they are still part of the world that supports us. They are made of water, connected to rivers, oceans, and life. Venus turns that familiar idea inside out. Its clouds are part of a world where the sky itself has become chemically hostile. That is why the descent keeps getting worse. Venus begins by hiding the surface. Then, it reveals that even the hiding layer is dangerous. The clouds are not a soft curtain over hell. They are the first layer of hell. And once a spacecraft enters them, the story is no longer about what Venus might be. It is about what Venus does to anything that tries to get inside. And one of the first things it does is attack with the sky itself. On Earth, the sky feels open. Even when clouds gather, even when storms build, there is still something familiar above us. Clouds are made mostly of water. Rain falls into rivers and oceans. Weather can be dangerous, but it belongs to the same system that supports life. The sky may frighten us during a storm, but it is also the place that gives Earth sunlight, air, rain, and climate. Venus takes that familiar idea and turns it into something hostile. Its clouds are not gentle water clouds, like the ones that drift above Earth. They are linked to sulfuric acid, forming a corrosive cloud layer that wraps the planet in brightness while hiding a world below. From outside, those clouds make Venus shine. From inside, they become part of the reason a descent would be so dangerous. This is where the beautiful mask becomes a chemical threat. A spacecraft entering the cloud layer would not be passing through harmless mist. It would be entering an atmosphere where the droplets and chemistry are hostile to ordinary materials. The planet's sky is not just thick. It is not just hot. It is not just toxic in the simple sense of having no oxygen. It is chemically aggressive. That means Venus begins destroying the fantasy before the surface even appears. The phrase acid clouds sounds almost exaggerated, but it is one of the most important parts of the Venus environment. The upper cloud deck is one of the reasons the planet looks so bright from Earth. Sunlight hits those clouds and reflects back into space, turning Venus into a brilliant point in our sky. But the same reflective layer is also a warning. It is not a soft white blanket over a peaceful world. It is a global chemical veil, and anything entering it has to survive that veil. For a human being, this alone would already be impossible without extreme protection. No person could breathe there. No skin, eyes, lungs, or exposed equipment could treat that air as normal. A spacesuit would not simply need to provide oxygen. It would need to resist chemistry, heat, pressure changes, and the entire hostile descent. On Venus, protection cannot be an afterthought. It is the difference between existing for a short time and being destroyed almost immediately. Imagine descending through the upper atmosphere of Venus. At first, there might be only brightness and haze. The planet's cloud tops would stretch in every direction, a pale and glowing ocean of atmosphere, with no visible land below. The sun would not feel like it does on Earth. Light would be scattered through thick layers. The view would become more yellow, more dim, more strange. You would not be falling through a clean blue sky toward an open horizon. You would be sinking into a chemical world. Layer by layer, the outside would become less like weather and more like a warning. The first danger is that the environment is not made for biology. Human life depends on a narrow range of conditions. We need breathable air, moderate pressure, survivable temperatures, and chemistry that does not immediately damage us. Venus offers none of that. Even high above the ground, the atmosphere belongs to a world that has drifted far away from anything Earth-like. The acid clouds are a sign of that separation. They show that Venus is not merely an overheated Earth. It is a different chemical reality. And chemistry is often what turns a dangerous place into an impossible one. Heat can burn. Pressure can crush. But corrosive chemistry can eat away at the materials meant to protect you. It can damage surfaces, weaken structures, and force engineers to think about every exposed part of a machine. On Venus, the environment does not wait at one point. It touches everything. A lander has to survive the planet's contact. Not just its gravity, not just its temperature, its atmosphere, its chemistry, its entire sky. This is one reason Venus is so much harder than it looks from a distance. A bright, cloud-covered planet might seem smoother and easier than a rocky world full of cliffs and craters. But a visible surface is not the only problem. Sometimes the atmosphere is the obstacle. Sometimes the sky itself becomes the terrain you have to cross. On Venus, the sky is not empty space above the mission. The sky is the first battlefield. The word battlefield is not about war. It is about resistance. A spacecraft descending through Venus must resist entry heating, chemical exposure, thickening air, rising temperature, increasing pressure, and finally, the surface conditions. It is being tested the entire way down. Every instrument, seal, cable, sensor, camera, and protective layer must face an environment that grows worse as the descent continues. Earth's atmosphere welcomes life. Venus's atmosphere tests machines until they fail. That difference is enormous. On Earth, atmosphere is protection. It shields us from many small meteoroids. It softens sunlight. It holds warmth, carries water, and allows sound, weather, flight, and breath. It is one of the reasons the surface is habitable. On Venus, the atmosphere has become the opposite kind of blanket. It traps heat too well, blocks the surface from view, and surrounds the planet with a hostile sky. An atmosphere can be life support, or it can be a prison. Venus is the prison version. The acid sky is especially disturbing because it uses something familiar against us. Clouds are among the gentlest images in human life. We see them in childhood drawings. We watch them drift over fields. We connect them with rain, shade, and the blue sky behind them. Venus keeps the shape of that idea, but removes the comfort. Its clouds are bright, global, and beautiful from far away, but they are not part of a living water cycle like Earth's. They are part of a deadlier system. This is why Venus feels like a corrupted mirror of Earth. It has clouds, but not clouds that mean what Earth's clouds mean. It has an atmosphere, but not one you can breathe. It has a surface, but not one you can stand on. It has sunlight, but that sunlight becomes trapped in a planet-wide furnace. It has many things that sound familiar, but the meaning of each one has changed. Familiar words become dangerous there. Sky, cloud, air, surface, warmth. On Venus, each word turns darker. The acid clouds are only the opening act. Below them, the atmosphere becomes thicker and heavier. The chemistry remains unfriendly. The heat grows, the pressure rises. A spacecraft that survives the cloud layer has not won. It has only passed the first gate. The planet still has more ways to destroy it. That is what makes the descent feel so relentless. Venus does not have one single hazard. It stacks hazards: a deadly atmosphere above, a crushing lower atmosphere below, a surface hot enough to destroy electronics and soften the meaning of machinery, a planet-wide environment where every layer is worse than the one before. This stacking of dangers is why the title is so strong. Before you even land is not just dramatic language. It captures the fact that landing is not the first moment of danger. On Venus, the approach itself is dangerous. The sky is dangerous. The clouds are dangerous. The lower atmosphere is dangerous. The planet begins to win before the ground enters the story. If you were inside a human-rated descent vehicle, the view outside might become almost meaningless. Windows, if they existed at all, would not show a clean world opening below. They would show haze, thick atmosphere, filtered light, maybe a yellowish gloom. The sense of direction could become dependent on instruments. The planet would not show you a welcoming landing field. It would surround you. This is another difference from a world like the Moon or Mars. The Moon has no thick atmosphere. Mars has a thin one. Both are dangerous, but they reveal their surfaces openly. Venus hides and surrounds. It is not just a place you go down to. It is a place you enter, like a deep ocean made of hot, toxic air. That ocean begins in the clouds, and it becomes heavier below. The acid part of the sky also raises a practical question. How does anything survive there at all? The answer is that spacecraft must be designed specifically for Venus. Materials, seals, coatings, electronics, and thermal systems all become critical. A probe cannot be treated as a normal lander with minor changes. The entire mission must respect the fact that Venus is a corrosive and extreme environment. Even then, survival is limited. The planet gives machines very little forgiveness. This makes Venus more frightening than a simple hot planet. If it were only hot, the story would be easier. If it were only toxic, the story would be easier. If it were only cloudy, the story would be easier. But Venus combines everything. The acid clouds make the descent hostile. The carbon dioxide atmosphere makes breathing impossible and heat trapping extreme. The pressure becomes overwhelming. The temperature becomes unbearable. It is not one problem. It is a system of problems. That system begins above the surface. The acid sky is the first real sign that Venus is not Earth's twin in any useful human sense. Earth has clouds that carry water. Venus has clouds that warn of a different chemistry. Earth's rain nourishes life. Venus's cloud environment would threaten materials and biology. Earth's sky opens into blue. Venus's sky closes into a harsh yellow world. The comparison is almost cruel. Venus looks like it should have a sky. Then, it gives you one you cannot survive. A human body is not only vulnerable to the absence of air, it is vulnerable to the wrong air. A person does not need to reach the surface of Venus to be in fatal danger. Without protection, the atmosphere itself is lethal. With protection, the equipment still has to resist chemical and physical stress. A safe descent would require a machine built like a fortress, a capsule that treats the sky as an enemy. And even a fortress would be temporary, because below the clouds, Venus is waiting with something worse. The acid sky does not crush like the lower atmosphere will. It does not melt like the surface heat will. But it announces the direction of the journey. It tells us that the planet has no gentle layer waiting for humans. There is no breathable zone on the way down. No familiar blue break in the clouds. No moment where the descent becomes easier. Only a path from hostile to more hostile. The beauty is real, but the beauty is not mercy. The acid clouds are the first mechanism of that trap. They hide the surface so completely that the planet can only be understood through instruments. They reflect sunlight so strongly that the planet shines like a jewel. They belong to a chemical atmosphere that no human could breathe or touch. And they lead downward into thicker, hotter, heavier layers that turn a dangerous sky into a deadly descent. This makes the cloud layer feel like a threshold. Above it, Venus is a bright object in space. Inside it, Venus becomes a hostile world. Below it, Venus becomes a machine for destroying anything fragile. And human beings are fragile. Even our strongest machines are fragile compared with a planet. A spacecraft is a careful arrangement of metal, electronics, insulation sensors, and power systems. Venus is an entire world of heat, pressure, and chemistry. The scale difference alone is humbling. We can build machines that cross millions of kilometers, but keeping them alive inside Venus is a different kind of challenge. The sky itself becomes a test chamber, a global one. That is why the surface of Venus does not need to be visible to be terrifying. The terror begins before the surface appears. It begins when you realize that the shining clouds are not a blanket over something gentle. They are the planet's first weapon. They are the chemical roof of a sealed world. Once you enter them, the old fantasy is gone. No jungle, no ocean, no second Earth. Only the acid sky and the deeper atmosphere waiting beneath it. This leads naturally into the next stage of the descent. After the cloud chemistry, the biggest change is not something sharp or sudden. It is something that builds around you. The atmosphere becomes thicker. The pressure grows. The air becomes heavier, denser, and more oppressive. Venus stops being just chemically hostile and begins to feel physically inescapable. The sky is no longer only attacking the surface of your spacecraft. It is beginning to press on it. And with every kilometer downward, that pressure becomes harder to ignore. This is where Venus stops feeling like a cloud-covered planet and starts feeling like something closer to a deep ocean made of air. At first, the word atmosphere sounds almost harmless. Earth has an atmosphere. It is the reason we can breathe, hear wind, watch clouds form, and see the sky turn blue. Around Earth, air is familiar. It is light enough to move through, gentle enough to forget, and thin enough that we can stand under it without thinking about the weight above us. But Venus has a very different kind of atmosphere. It is not a thin, breathable layer wrapped around a comfortable world. It is a massive, dense, toxic envelope that dominates the planet. It is not just something above the surface. It is part of the planet's identity. On Venus, the atmosphere is so important that you cannot understand the world without understanding the air. Because the air is not empty space. The air is the danger. A descent through Venus would not feel like dropping through the atmosphere of Earth. On Earth, as you come down through the sky, the world becomes more familiar. The air becomes breathable, the ground becomes visible, the pressure reaches the level our bodies are made for. You descend towards safety, at least compared with the vacuum of space. On Venus, the descent moves in the opposite emotional direction. The lower you go, the worse it gets. The atmosphere becomes thicker, the temperature rises, the pressure builds, the sky becomes more oppressive. Instead of approaching a world where a human could survive, you are moving deeper into a planetary system that becomes more hostile with every layer. This is why Venus would kill you before you land. The surface is not the first problem. The atmosphere is already becoming one. Imagine a spacecraft sinking below the cloud tops. Above, Venus looked like a smooth, bright sphere. Around you now is haze, chemical danger, and a sky that no longer feels open. The planet is still hiding the ground, but the instruments already know the truth. The air is growing heavier. The descent is no longer just about altitude. It is about entering a deeper and deeper atmospheric weight. On Earth, we rarely think about the weight of air, because we are built for it. The atmosphere presses on us, but our bodies push back. We evolved at Earth's surface, so one atmosphere of pressure feels normal. It does not feel like being crushed. It feels like simply existing. Venus destroys that normal feeling. The deeper you go, the more the atmosphere becomes something you cannot ignore. It is not just surrounding the spacecraft. It is pressing against it. It is pushing on every surface. It is filling every direction. The vehicle is not falling through emptiness anymore. It is forcing its way into a dense planetary blanket. This changes the meaning of air. On Earth, air is almost invisible freedom. On Venus, air becomes weight. That is a frightening idea, because humans are used to treating air as the soft part of a planet. Rock is hard, metal is hard, ice can be hard. But air feels gentle. We move our hands through it, birds fly through it. Wind can become powerful, but ordinary air feels like nothing. Venus shows that atmosphere can become something far more physical. Air can become a crushing environment. Before the true surface pressure is reached, the thickening atmosphere already changes the descent. A spacecraft has to resist drag, heat, chemistry and pressure. Its parachutes, if used, behave differently in dense air. Its instruments must work in conditions that become more severe with time. Its communication systems have to keep sending data through an atmosphere that grows deeper and more hostile. Everything becomes a countdown, not just to landing, to failure. This is one of the most unsettling parts of Venus exploration. A probe, descending through the atmosphere, is not moving toward a stable, safe zone where conditions improve. It is moving toward a place where survival becomes harder every minute. Every kilometer downward brings more atmosphere above it. More heat, more pressure, more stress. The planet does not simply wait below. It begins squeezing from above. This is why comparing Venus to Earth's evil twin is so effective, but also incomplete. Venus does not only have a different surface, it has a different sky, a different atmospheric mass, a different kind of planetary envelope. It is not Earth with bad weather. It is Earth's basic shape pushed into a completely different atmospheric reality. On Earth, the atmosphere is thin compared with the size of the planet. On Venus, the atmosphere feels like a heavy world of its own. If you could somehow float inside it, the sensation would not be the freedom of flying through open air. It would be the feeling of being immersed in something thick, hot, and toxic. The sky would not feel like empty space above a landscape. It would feel like a dense layer pressing around you, blurring distance, hiding the ground, and turning the act of descending into a struggle. The atmosphere is not the pathway to the surface. It is part of the trap. A useful way to imagine this is to think about diving underwater, but even that comparison is imperfect. As a diver goes deeper into Earth's ocean, pressure increases because more water is above them. On Venus, descending through the atmosphere has a similar emotional feeling. The lower you go, the more weight is above you. But instead of water, it is hot carbon dioxide atmosphere. Instead of a cool ocean, it is a toxic sky leading toward a furnace. It is not an ocean of water. It is an ocean of air that behaves like a threat. This is why the pressure chapter becomes unavoidable. Next, but before the crushing surface pressure, it is important to feel the transition. Venus does not instantly switch from cloud layer to surface. It has depth. A descent through that depth would reveal the planet gradually, and every stage would teach the same lesson. The atmosphere is not becoming more Earth-like as you approach the ground. It is becoming less survivable. The deeper layers are not hiding comfort. They are hiding punishment. As the air thickens, the idea of a human standing on Venus becomes more and more absurd. A person cannot simply bring oxygen and solve the problem. Breathing is only one small part of survival. A human body must also survive pressure, heat, and chemistry. A suit must not only contain breathable air, it must hold its shape, protect against crushing forces, prevent chemical damage, manage heat, and keep the person alive in an environment that attacks from every direction. On Mars, a suit has to protect a human from thin air and cold. On Venus, a suit would have to resist the planet itself. That difference is enormous. The atmosphere would also affect motion. A descent vehicle would slow in the thick air, but slowing is not the same as safety. Dense atmosphere can help with braking, but it also means the vehicle is surrounded by a medium that transfers heat and pressure. The air that helps slow you down is the same air that becomes heavier, hotter, and more hostile as you continue. Venus gives with one hand and destroys with the other. It can slow a falling spacecraft, then crush and cook it. This is why landing there is not simply about reaching the ground gently. On another planet, the question might be whether the spacecraft can avoid crashing. On Venus, avoiding a crash is only the beginning. The real question is whether the machine can survive the atmosphere long enough to land, send data, and remain functional in conditions that become worse after touchdown. A soft landing does not mean a safe landing. On Venus, Even success is temporary. The thickening atmosphere also changes visibility. As you fall lower, the world would not become clear and welcoming. The light would be filtered, scattered, and altered. The sky would not be blue. The view would be strange, heavy, and alien. The surface might eventually appear as a harsh, dim landscape under a dense yellow-orange atmosphere. But by then, the vehicle would already be deep inside the planet's danger zone. The view arrives late, the danger arrives early. That is one of the cruel patterns of Venus. The planet hides what you want to see and reveals what can kill you first. Before you see the ground clearly, you experience the atmosphere. Before you touch the surface, the pressure rises. Before you walk anywhere, the heat begins to win. The descent itself is the warning. Venus does not need to surprise you at the final moment. It makes the entire journey downward feel wrong. The thick atmosphere also explains why Venus feels so sealed. Earth's atmosphere is open to life. It circulates water, carries oxygen, and allows energy to escape enough for the climate to remain within livable limits. Venus's atmosphere is more like a closed system of heat and pressure. The surface is buried under it. The sky does not feel like a pathway outward. It feels like a lid. That lid is heavy, and below it, the world is trapped. As a spacecraft descends, this power becomes physical. The atmosphere is no longer a number in a scientific description. It is the thing pressing against the vehicle. It is the thing slowing it, heating it, surrounding it, and gradually turning the descent from exploration into endurance. Every layer makes the machine work harder. Every layer makes the environment less forgiving. The term landing almost feels too simple for Venus. Landing suggests a final event, touchdown. But on Venus, the critical story begins earlier. The spacecraft must survive entry. It must survive the clouds. It must survive the thickening atmosphere. It must survive the pressure. It must survive the heat. Touchdown is not the end of the danger. It is only the moment when the danger stops increasing downward and becomes a constant attack from all around. That is why the descent matters so much. A mission to Venus is not a fall to the surface. It is a passage through a planet-wide machine. The machine is built from atmosphere, chemistry, pressure, and heat. It has no moving gears in the human sense, but it works relentlessly. It does not need to target you. It does not need storms or explosions. It only has to exist. A spacecraft that enters Venus must deal with the basic state of the planet, and the basic state is enough to destroy almost anything unprepared. Venus is lethal without trying. If a human could somehow watch the descent from inside a protected craft, the psychological effect would be enormous. The numbers on the instruments would move in the wrong direction. Temperature rising, pressure rising, exterior conditions worsening. The planet below still hidden or only slowly appearing. No breathable layer. No emergency exit. No open sky that feels safe. The deeper you go, the less Earth-like the twin becomes. The planet's similarity fades with altitude. By the time you approach the lower atmosphere, the old comparison with Earth becomes almost meaningless. Same size does not matter. Rocky surface does not matter. Brightness does not matter. What matters is that the air has become a crushing, heating, toxic mass between you and survival. Venus is not a place where a human body fails because of one missing condition. It is a place where every condition is wrong at once. This is also why Venus can be more frightening than places that are obviously impossible. A gas giant has no solid surface in the ordinary sense, so the danger feels alien from the start. The sun is obviously deadly. The vacuum of space is obviously hostile. But Venus has a surface. It has a sky. It has clouds. It is a rocky planet. It has just enough familiar pieces to lure the mind into imagining a landing. Then, the atmosphere takes those pieces away. A surface under this atmosphere is not a place for a walk. A sky like this is not a sky for breathing. A planet like this is not a second home. As the atmosphere grows thicker, the future of the descent becomes obvious. The next danger is not only chemical or visual, it is mechanical. The outside world begins to press harder and harder on the spacecraft. The pressure becomes not just a condition, but a force that must be survived. Every seal, every wall, every instrument housing must resist the weight of the Venusian atmosphere. The planet stops being something you fall through. It becomes something that tries to squeeze you. That is the next stage, the crushing pressure. And it is where the idea of landing on Venus becomes even more impossible. Because below the acid clouds and thickening atmosphere, Venus begins to reveal one of its most brutal weapons: pressure. Not pressure as an idea, not pressure as a number in a textbook, but pressure as a physical force pressing against every surface, every seal, every wall, every instrument, and every fragile part of anything trying to descend. On Earth, air pressure is so normal that we forget it exists. It surrounds us gently. It presses on our bodies, but our bodies are built for it. We move through it, breathe it, and barely think about the weight of the sky above us. On Venus, the sky has weight in a completely different way. The lower atmosphere is not just air. It is a crushing mass. A spacecraft, descending toward the surface, would not simply be falling through a toxic atmosphere. It would be entering a world where the atmosphere becomes heavier and heavier, until it presses with a force far beyond anything human beings could survive without extreme protection. This is one of the reasons Venus is so much worse than it first appears. A rocky surface sounds familiar. A cloudy atmosphere sounds familiar. Even the word planet feels familiar. But the pressure at the surface of Venus is not familiar at all. It is often compared to being deep under Earth's ocean, because that is one of the few experiences on Earth that helps the human mind understand what crushing pressure means. But even that comparison is disturbing. Imagine leaving the open air and sinking down into the sea. At first, the water surrounds you softly. Then the deeper you go, the more the weight above you increases. Your body feels the pressure. Equipment has to be built stronger. Submarines need reinforced walls. The ocean becomes less like open space and more like a force from every direction. Now replace that ocean with hot, toxic carbon dioxide atmosphere. That is the emotional reality of Venus. Not water. Air. Air that behaves like something heavy enough to crush. That makes the idea of standing on Venus almost impossible. A human body is built for Earth's surface pressure. If you were exposed to the surface of Venus without protection, breathing would already be impossible. Chemistry would already be hostile. Heat would already be deadly, but the pressure alone would be catastrophic. It would press against you from every direction, not like a single weight falling from above, but like the entire atmosphere squeezing inward. Pressure does not attack from one side. It surrounds. That is what makes it so terrifying. A spacecraft has the same problem. It does not only need to land softly, it needs to remain sealed while the atmosphere pushes on it. Every window, every joint, every sensor opening, every protective shell must resist the pressure outside. A small weakness could become fatal to the machine. A tiny failure in a seal could let the hostile atmosphere enter. Electronics, cameras, batteries, and instruments must be protected not only from heat, but from the mechanical force of the planet's air. The atmosphere is trying to get in. Not intentionally, not like a creature, simply because pressure works that way. The outside pushes harder than the inside can tolerate, unless the spacecraft is built like a pressure vessel. This is why Venus landers have always been engineering battles against the environment. The machine must carry its own survivable internal world into a place where the external world is violently incompatible with delicate technology. In a sense, Any Venus lander is a tiny Earth-like bubble, a small protected pocket of instruments and structure, lowered into a planetary atmosphere that wants to destroy it. And the lower it goes, the more that outside world wins. This is why the descent feels so different from Mars. Mars is dangerous because its atmosphere is extremely thin. A human there would need pressure inside a suit because there is not enough outside pressure. Venus is the opposite. Venus has far too much outside pressure. On Mars, your protection fights emptiness. On Venus, your protection fights overwhelming density. Both can kill, but they kill in opposite ways. Mars takes pressure away. Venus gives far too much. That contrast helps explain why Venus is such a strange nightmare. Space danger is often imagined as emptiness, freezing darkness, and vacuum. Venus is not that. Venus is a world where the danger comes from too much atmosphere, too much trapped heat, too much weight above you. It is not the silence of emptiness. It is the violence of excess. A human would not float away. A human would be crushed, cooked, and poisoned. The pressure is especially important because it makes simple solutions meaningless. You cannot just bring an oxygen tank. You cannot just wear a suit like you would in a thin atmosphere. You cannot just build a normal habitat and place it on the ground. Everything must resist the constant force outside. The structure would need to survive as if it were deep under an ocean, while also enduring heat that makes ordinary engineering far harder. Machines can be built to survive pressure. Machines can be built to survive heat. Machines can be built to survive corrosive chemistry for some time. But Venus asks for all of it at once, continuously, in an environment where failure means the planet immediately wins. The pressure is not temporary. There is no relief after landing. There is no cool night where conditions become easy. There is no open air outside the habitat. There is only the same crushing atmosphere pressing all the time. This constant pressure changes the feeling of the planet. Venus is not a place where danger passes over you. It is not a storm that ends. It is not a cold night you can wait out. It is a permanent condition. The surface atmosphere is always heavy. The environment is always hostile. The planet's normal state is the emergency. That is why the word landing almost becomes misleading. Landing usually sounds like arrival. A spacecraft touches down. The dangerous journey is over, and exploration begins. On Venus, touchdown would not end the danger. It would only place the spacecraft at the bottom of the pressure system, where the atmosphere is heaviest and the surface conditions are most extreme. Landing is not escape from the descent. Landing is entering the worst layer. That is the opposite of how landing feels in human experience. On Earth, landing means returning to the ground, to safety, to stable air. On Venus, landing means reaching the place where pressure, heat, and atmosphere have reached their maximum cruelty. The surface is not a safe endpoint. It is the deepest part of the trap. The spacecraft would not be resting. It would be enduring. A photograph from the surface of Venus does not need to show fire to be terrifying. It can show rocks, a dim sky, a strange horizon, and still be one of the most hostile places ever photographed. The danger is mostly invisible in a still image. Pressure cannot be seen directly. Heat cannot always be seen. Toxic air cannot be understood by the eye alone. But those invisible conditions define the whole scene. The surface looks like a place. The measurements reveal a punishment. But even the ocean comparison has limits. Under Earth's ocean, pressure increases, but the water can be cold. On Venus, the pressure comes with heat. The lower atmosphere is not a dark, cold deep. It is a hot, dense, toxic sky above a furnace-like surface. There is no comforting analogy on Earth that captures all of it at once. Venus is not just one Earth environment made worse. It is several nightmares combined. Deep ocean pressure, poisoned air, acid clouds above, oven heat below, and no breathable layer anywhere. A human mission would multiply the difficulty. Humans need space, air, temperature control, pressure control, radiation protection, food, water, power, communication, emergency systems, and the ability to return. On Venus, even staying alive on the ground for a short period would require an artificial environment stronger and more protected than almost anything we associate with planetary exploration. And returning would be even harder. A spacecraft would need to launch from the bottom of a dense, crushing atmosphere, through heat, pressure, and drag, back toward orbit. Leaving Venus would not be like stepping into a small rocket from the moon. It would mean fighting upward through the same atmosphere that made landing so punishing in the first place. Venus does not only make arrival deadly, it makes escape terrifying. The crushing pressure is central to that feeling. It turns the surface into a hostile chamber. It makes every second after touchdown a test. It makes human presence almost unimaginable without technology so strong that the mission begins to feel less like exploration and more like entering an industrial pressure vessel on another planet. There would be no stepping outside, no casual footprint, no human hand touching Venusian rock, no helmet removed for a dramatic moment. The outside world would be death immediately. A normal human body is soft. Venus is not. That contrast is brutal. Human life is delicate, dependent on narrow conditions. Venus is massive, indifferent, and extreme. The planet does not need to hate life to destroy it. It simply has conditions that life like us cannot handle. Pressure is one of those conditions because it turns the atmosphere itself into a force. And the force is everywhere. Above, around, against every surface, against every weak point. There is no direction where pressure is absent. The pressure also helps explain why Venus is so sealed and stagnant in feeling. The thick atmosphere creates a sense of enclosure. It makes the surface feel buried, not exposed. The ground is not open to space in the way the moon is. It is not under a thin sky like Mars. It is covered by a massive atmospheric load that separates it from the universe above. Venus is not empty. It is buried under its own sky. That is one of the strongest images for this chapter. A planet buried under atmosphere. The surface exists, but it is not open. It is hidden under clouds, sealed under carbon dioxide, pressed under enormous weight, and baked by trapped heat. If Earth's atmosphere is a life-giving blanket, Venus's atmosphere is a lid that became too heavy. The lid is the planet. The lid is the prison. The lid is why the surface is so unreachable in any human sense. As the descent vehicle approaches the ground, the pressure would be near its most extreme. The lander's shell would have to keep its shape. Its systems would have to keep functioning. If it carried cameras, they would have to see through dense, hot air. If it carried sensors, they would have to measure without failing. If it carried a human crew in some imagined future, the habitat would have to protect them from a world pressing on every wall. Inside, everything would depend on engineering. Outside, everything would be Venus. And Venus would be stronger. This does not mean exploration is impossible. In every form, robots have reached the surface. Measurements have been made. Images have been sent back. Human technology can survive Venus for limited times when designed carefully enough. But survival there is not casual. It is not easy. It is not the kind of place where a machine lands and calmly operates for years like a rover on Mars. On Venus, time itself becomes expensive. Every minute on the surface is a victory. Every signal is a victory. Every image is a victory. Because the pressure, heat, and atmosphere are always attacking the mission. The crushing pressure is the part that makes Venus feel physically oppressive. Acid clouds make it chemically hostile. Heat makes it thermally lethal. But pressure makes the planet feel heavy. It turns the air into something that has mass in the imagination, something that leans on the spacecraft, something that makes the entire surface feel buried. And yet, pressure is only one part of the final punishment. Because even if a machine could survive being squeezed, it would still have to survive being cooked. This is the next horror of Venus. The atmosphere does not only crush, it traps heat so effectively that the surface becomes one of the hottest places in the solar system. So after the pressure comes the furnace, the heat that melts metal. And that heat is where Venus stops being merely impossible for humans and becomes almost impossible for machines as well. Because even if you could build something strong enough to resist the pressure, even if it could survive the acid clouds and the toxic atmosphere, Venus still has another weapon waiting below: heat. Not desert heat, not summer heat, not the kind of heat a human can imagine by standing near fire or walking across hot sand. Venus has planetary heat, trapped under a massive carbon dioxide atmosphere, sealed beneath clouds, held close to the ground until the surface becomes a furnace. This is the part of Venus that makes the word landing feel almost meaningless. A lander would not simply touch rock. It would touch rock inside an oven that covers an entire planet. The surface temperature of Venus is high enough to melt lead. That single fact changes everything. Lead is not a fragile material in the everyday imagination. It is heavy, metallic, solid, and physical. Yet on Venus, the normal surface heat is enough to push it past its melting point. This is not a rare event, not a volcanic blast, not a temporary firestorm. This is the ordinary condition of the planet's surface. Venus does not need flames to be deadly. The air itself is hot enough. This is what makes Venus so different from the way it looks in the sky. From Earth, it shines softly, almost like a pearl. But under the clouds, the surface is heated to a level that no human body could tolerate for even a moment. Skin, lungs, blood, nerves, and organs are built for the narrow temperature range of Earth. Venus is not outside that range by a little. It is outside it completely. A person exposed there would not be in danger. They would be finished. And the terrifying part is that heat does not care about bravery. It does not care about strength training or preparation, unless the protection is absolute. You cannot tough your way through Venus. You cannot run across the surface quickly. You cannot take one step outside for a few seconds. The heat is not something you endure. It is something that destroys the conditions required for a human body to remain alive. This is why a spacesuit on Venus would have to be far more than a suit. It would have to be a cooling system, pressure vessel, chemical shield, life support chamber, and walking fortress all at once. And even then, the outside world would constantly try to push heat inward. Every second would be a battle against temperature. Every surface exposed to the Venusian environment would absorb heat. Every seal, joint, and material would have to survive in conditions that make ordinary engineering fail. On Earth, heat can often be escaped. You move into shade. You enter water. You find night. You go indoors. On Venus, there is no simple escape. The heat is everywhere near the surface. It comes from the environment itself. The thick atmosphere spreads and traps warmth so effectively that the night side of Venus is not a cold refuge. The planet rotates slowly, but the lower atmosphere distributes heat in a way that keeps the surface brutally hot. This is not a place where you wait for sunset and survive. There is no gentle evening coming to save the mission. The furnace does not turn off. That is one of the most haunting things about Venus. It is not only hot because it faces the sun. It is hot because its atmosphere has turned the surface into a sealed thermal prison. The heat is not just sunlight hitting the ground. It is sunlight trapped, recycled, and held inside a dense atmosphere until the entire lower world becomes nearly uniform in its hostility. The sky above Venus is not simply above the heat. The sky helps make the heat. This is the runaway greenhouse nightmare. On Earth, greenhouse gases help keep the planet warm enough for oceans and life. A controlled greenhouse effect is part of why our world is habitable. But on Venus, the heat-trapping system became extreme. The atmosphere is dominated by carbon dioxide, and the planet's thick air holds heat with terrifying efficiency. The result is a world hotter than Mercury in many ways. Even though Mercury is closer to the Sun, that feels wrong at first. Mercury orbits closest to the Sun. It receives intense sunlight. Its day side becomes extremely hot. But Mercury has almost no atmosphere to trap and redistribute heat in the same way. Venus, farther out, is wrapped in a dense heat-trapping atmosphere. It does not simply receive sunlight. It keeps it. That difference is everything. Venus teaches that distance from the Sun is not the only thing that decides a planet's fate. Atmosphere can dominate the story. A planet can be closer to Earth's size than almost any other world and still become completely uninhabitable if its atmosphere drives the climate into a catastrophic state. That is why Venus feels like a warning. Not because Earth is about to become Venus tomorrow, but because Venus shows how powerful atmosphere can be. It shows that climate is not a thin detail painted onto a planet. It can define the entire world. It can decide whether a surface has oceans or ovens, rain or acid, breathable air or suffocating pressure. The atmosphere of Venus is not an accessory. It is the system that turned a rocky planet into hell, and at the bottom of that system, the heat waits. For a spacecraft, this heat is a nightmare, because machines have limits. Electronics do not like extreme heat. Batteries do not like extreme heat. Cameras, sensors, cables, transmitters, and computers all need conditions that allow them to function. On Earth, we protect electronics from overheating because even mild overheating can damage them. On Venus, the environment is not mildly warm. It is hostile enough to destroy ordinary electronics rapidly. A Venus lander must therefore carry its own protection. It must keep its inner systems alive while the outside world tries to cook them. This turns the mission into a race against time. The lander may survive entry, it may survive the clouds, it may survive the pressure. It may touch down successfully, but after landing, heat begins to win. The outer shell can slow the process. Insulation can delay failure. Cooling systems can buy time. Strong design can extend the mission. But the planet is patient, and the heat is constant. Eventually, the inside warms. And when the inside warms enough, the machine dies. This is why surface missions to Venus are often measured in minutes or hours, not years. A rover on Mars can operate for a long time because the environment, while dangerous, is not constantly cooking the machine at lead-melting temperatures. On Venus, long-term survival on the surface is much harder because every moment is spent inside an oven. The clock starts before touchdown, and it keeps ticking faster after landing. Heat also changes materials. Metals expand, components weaken, lubricants fail, circuits struggle, cameras and sensors lose reliability. The structure may remain intact for a time, but the delicate systems inside are living on borrowed minutes. A Venus lander is not only fighting to avoid being crushed, it is fighting to keep its own brain from overheating. That makes Venus feel almost unfair to machines. A lander can be strong and still fail. It can be sealed and still fail. It can land successfully and still fail. Because on Venus, the environment is not a single obstacle to pass. It is a permanent attack. A human body is mostly water and delicate tissue. It depends on temperature regulation. It depends on proteins remaining stable. It depends on blood, nerves, and organs functioning inside a narrow range. Venus is so far beyond that range that the body would fail almost instantly without perfect protection. The heat would not be a discomfort. It would be a complete rejection of biology. Venus does not just lack life support. It actively destroys the conditions life needs. This is why the surface of Venus can be described as a furnace. But even that word is not perfect. A furnace is usually something built for heat, controlled by humans, turned on and off for a purpose. Venus is a natural planetary furnace with no switch, no safe edge, and no nearby room outside the heat. The furnace is the world. The rocks are in it, the atmosphere is in it. A spacecraft is in it. Anything that lands becomes part of it. The heat also changes the emotional feeling of Venus compared with colder worlds. Mars feels lonely, dusty, and frozen. The outer moons feel dark and icy. Pluto feels remote and silent. Venus feels suffocating and close, as if the planet is pressing in with both weight and temperature. It is not the fear of cold emptiness. It is the fear of being trapped in a place that is too full of atmosphere and too full of heat. A cold world might preserve a machine. Venus consumes it. The surface itself, if viewed by a camera, might not look as dramatic as the conditions suggest. It may show rocks, flat ground, a strange sky, and a dim orange-yellow light. There may be no visible fire, no lava in the frame, no obvious flames wrapping around the spacecraft. The image might look almost quiet, but that quietness would be misleading. The danger is invisible. The heat is in every molecule of air. The pressure is in every direction. The chemistry is in the atmosphere. Venus can look still while destroying you. That is part of the terror. Human beings are visual creatures. We expect danger to show itself. We expect fire to glow, storms to roar, cliffs to drop away, oceans to rage. Venus does not need to perform danger for the camera. A calm rock field under a dim sky can still be hot enough to melt lead and pressurized enough to crush unprotected systems. The measurements make the image horrifying. Without them, the photograph does not tell the whole truth. The heat also explains why the atmosphere is so central to the entire story. If Venus had a thin atmosphere, the surface might cool more effectively. If it had a different atmospheric history, the planet might have followed another path. But the thick carbon dioxide atmosphere traps heat so well that the surface becomes locked into extreme conditions. The heat and atmosphere are not separate problems. They are tied together. Pressure and heat are partners. The same thick atmosphere that crushes also helps cook. This pairing makes Venus one of the clearest examples of how planetary environments are systems. You cannot remove one danger and understand the planet. The clouds, chemistry, pressure, and heat all connect. The clouds hide and reflect. The atmosphere traps heat. The pressure increases downward. The surface becomes unbearable. A mission must survive all of it. Venus is not hostile in pieces. It is hostile as a whole. This is why Venus kills before landing in layers. First, the atmosphere denies breath. Then the clouds bring chemical danger. Then the air thickens. Then pressure becomes crushing. Then heat becomes absolute. By the time the surface is close, a human being is not simply in danger from one thing. They are surrounded by a complete world that is wrong for them. Venus is not a place with hazards. Venus is the hazard. The heat is the final confirmation of that idea. A planet can have toxic gas, and maybe a sealed suit can handle it. A planet can have high pressure, and maybe a reinforced vessel can handle it. But combine those with heat high enough to melt lead, and survival becomes a much shorter and more brutal problem. The environment attacks the structure, the electronics, the cooling system, and the idea of long-term presence at the same time. This is why machines die so quickly there. And that brings us to the next part of the journey. Because Venus is not just dangerous in theory, we know it is dangerous because machines have actually gone there. Probes have descended through the clouds, landers have reached the surface. Some have sent back data and images, but none of them found a gentle twin of Earth waiting below. They found a world that slowly destroyed them. The next question is not whether Venus is deadly. The next question is how long even a robot can survive after entering the furnace. Because Venus is not only deadly to humans, it is deadly to machines. That is what makes the planet so different from a simple exploration challenge. On Mars, a rover can land, open its cameras, drive across the dust, and keep working for months or years if the system survives the cold, dust, and radiation. On the Moon, machines can sit under a black sky and return data as long as power and temperature are managed. In deep space, probes can travel for decades through silence. But Venus is different. On Venus, survival is measured brutally. A spacecraft does not land and begin a long, peaceful mission. It lands and begins losing a fight. The planet attacks from every direction at once. Pressure pushes inward. Heat seeps through insulation. Chemistry touches exposed parts. The atmosphere surrounds the lander like a hot, dense ocean. The machine is not simply sitting on a surface. It is trapped inside the lower layer of a planetary furnace. This is why robotic missions to Venus are so important. They proved what the clouds had hidden. They did not just tell us Venus was dangerous from far away. They entered the atmosphere, descended through the sky, reached the surface, and experienced the planet directly. They measured the conditions, they sent back data. Some even sent images from the ground. And then they died. That ending is not a failure in the ordinary sense. On Venus, even a short survival is a victory. A lander that works for minutes on the surface has already done something extraordinary. It has crossed millions of kilometers of space, entered one of the most hostile atmospheres in the solar system, survived the descent, touched the ground, and sent information back through a world trying to destroy it. Every signal from the surface is like a message sent from inside a furnace before the door closes. That is why Venus surface images feel so strange. They are not just photographs. They are last words from a machine. The surface may show rocks, a flat horizon, a dim sky, and a strange alien light. It may not look dramatic in the way people expect. There may be no visible flames, no glowing lava, no explosive storm in the frame. But the quietness of the image is exactly what makes it haunting. The photograph looks calm, while the conditions around the camera are catastrophic. The camera is dying while showing a still world. That is Venus. It destroys without needing to look violent. The reason probes die so fast begins with heat. Electronics are delicate. Even on Earth, devices overheat. Computers need cooling. Batteries have safe operating ranges. Cameras, sensors, transmitters, and circuits all depend on temperature staying within limits. When heat rises too far, materials expand, components fail, signals degrade, and systems stop working. On Venus, the surface heat is not a temporary spike. It is the normal environment. A probe can carry insulation, but insulation only slows the heat. It does not erase the planet. A lander can be built with protective shells and thermal systems, but the outside world keeps pushing heat inward. Every minute, the interior becomes harder to protect. Eventually, the electronics reach temperatures they cannot survive. The machine's brain overheats. Then, the mission ends. This is why Venus is not like a cold world where a machine might hibernate and wake again. On Venus, the problem is not waiting for sunlight or conserving power through a frozen night. The problem is that the environment is continuously forcing heat into the spacecraft. The planet is always on. The furnace does not cool down for the lander. There is no safe shade, no cold night, no gentle recovery period. Heat is the countdown. But heat is not alone. Pressure is the second reason probes die quickly. The lower atmosphere presses with enormous force. A lander must be strong enough to keep its shape and protect its interior. If a shell bends, if a seal fails, if a pressure boundary breaks, the hostile atmosphere can enter and the mission can end quickly. This means the lander has to be both protected from heat and built to resist pressure. That combination is difficult. A pressure vessel can be strong, but it must also manage temperature. Insulation can protect electronics, but it must survive pressure and chemistry. Openings for cameras and instruments must work without becoming weak points. The machine must communicate, measure, and photograph, while the planet pushes on every surface. Every part has to survive Venus. Not just the legs, not just the shell, everything. This is why a Venus lander is not simply a robot with wheels or cameras. It is a survival capsule. It has to carry its own temporary, safe environment for its systems. It has to stay alive long enough to do science before the outside conditions overwhelm it. The word temporary is important. On many missions, engineers try to build for long-term operation. On Venus, the first goal is often to survive long enough to return the most valuable data before failure becomes inevitable. The planet sets the clock. The lander tries to beat it. Venus turns exploration into a race. The third reason probes die quickly is chemistry. The clouds and atmosphere are not friendly to exposed materials. Corrosive conditions can damage parts, and the atmosphere is mostly carbon dioxide, not the gentle mixture of gases around Earth. Even if the lander is sealed, anything outside has to face the planet directly. Exterior sensors, camera windows, structural parts, antennas and surfaces. On Venus, the outside world is not just hot and heavy, it is hostile in composition. That makes design harder again. A probe must not only survive a number on a temperature gauge or a pressure gauge. It must survive a real environment where heat, pressure, and chemistry act together. A material that survives. One stress may struggle with another. A system that works in a laboratory must still work after entry, descent, landing, and surface exposure. Venus does not test one weakness. It searches for all of them. The fourth reason is time. Not time as a schedule, but time as exposure. A probe may survive extreme conditions for a short period, but the longer it remains there, the more heat penetrates, the more stress accumulates, and the more likely a system becomes to fail. On Venus, every extra minute is harder than the last, because the machine is being soaked in the environment. Survival is not only about reaching the surface, it is about how long the lander can delay the planet. That is why the history of Venus landers feels so dramatic. Robotic missions showed that the surface could be reached, but they also showed how unforgiving it is. Some probes failed before returning surface data. Some survived the descent, but did not last long on the ground. Others successfully transmitted measurements and images, giving humanity rare glimpses of the hidden world. The images were priceless because they were brief. They came from a place that does not let machines remain comfortable. When we see a surface photo from Venus, it should feel different from a Mars rover image. A Mars rover image can feel like the beginning of a journey. A Venus surface image feels like a message from a place where the clock is already running out. The machine is not preparing for years of travel. It is transmitting what it can before the heat wins. That makes every frame feel urgent, even if the landscape looks still. A rock on Venus is not chasing the lander. The sky is not visibly exploding, but the environment is destroying the machine anyway. The quiet image hides an active battle. That is why humans needed machines to go there. The human eye from Earth could not see through the clouds. A telescope could not stand on the surface. Radar could map hidden terrain, but a lander could feel the planet directly through instruments. Robotic probes became our temporary sensors inside Venus. They touched the world for us. They breathed the numbers for us. They saw the ground for us. And then, the planet took them. That silence is part of the story. The signal stops, not because space became empty, because Venus became too much. The surface is not waiting for astronauts in the usual sense. It is waiting for specialized machines designed to survive just long enough. Even future technology may improve endurance, but the basic problem remains. The environment is brutally hot, pressurized, and chemically hostile. Venus is not made easier by hope. It is made understandable by engineering, and engineering has to respect the planet. Venus does not negotiate. It sets conditions. Every probe has to obey them. They also reveal something deeper. Venus is not unknown because we have ignored it. It is hard to know because it resists being known. The clouds hide the surface. The atmosphere complicates descent. The heat limits survival. The pressure demands strong engineering. The planet allows only brief visits to its ground. Every piece of knowledge has to be earned against the environment. Science on Venus is expensive in difficulty. A few minutes can become historic. A single image can matter for decades. A pressure reading can change our understanding of an entire planet. That is an important distinction. Machines die, but their information leaves Venus. It travels upward as radio signals, crosses space, reaches Earth, and becomes part of human knowledge. The lander may stop functioning, but the measurements remain. The surface may crush and cook the hardware, but it cannot undo the message already sent. In that sense, every Venus lander is a messenger that knows it will not last. It enters the planet, speaks quickly, and falls silent. This gives Venus exploration a haunting rhythm. Approach, descent, survival, transmission, failure, silence. The mission timeline itself feels like a story of entering a dangerous place with a limited voice. The spacecraft cannot stay long, so it must tell us what it sees before the environment closes in. That is why Venus surface data feels precious. It comes from a world that does not allow long conversations. The reason robots die so fast is not mysterious once we understand the conditions. It is the combined result of heat, pressure, chemistry, and time. But emotionally, it still feels shocking. Machines are supposed to be tougher than humans. They cross space, they survive launch, they operate in vacuum, they endure radiation and cold. They send signals across millions or billions of kilometers, and yet Venus kills them. A planet that looks like a bright star in our sky can defeat machines built for space. That contrast makes Venus feel almost personal. It is not only dangerous to biology, it is dangerous to technology. It reminds us that our machines are not magic. They are physical things made of materials, circuits, and limits. When placed inside the wrong environment, they fail. Venus is the wrong environment. Completely. This is why the short lives of past probes are so important for the human imagination. They are proof that the surface is not simply hard in theory. It has already ended missions. It has already silenced machines. It has already shown us that landing successfully is only the first stage of failure, unless the spacecraft can keep itself alive. On Venus, touchdown can be the beginning of death. That is a rare and powerful idea. Most people think of a landing as the success moment. The spacecraft has arrived. The danger is behind it. The mission begins. On Venus, landing means the mission has reached the place where the planet is strongest. The descent is over, but the environment is now maximum. The machine has not escaped danger. It has entered the deepest part of it. As we move from robotic probes to human survival, the question becomes unavoidable. If machines can only endure Venus for a limited time, what hope would humans have? Could there ever be a way to survive there, even briefly? Could we build habitats, floating stations, armored suits, or machines strong enough to make Venus less impossible? The answer is complicated, because the surface is almost hopeless for humans with current thinking. But Venus has another strange layer to its story. The ground is hell. Yet high above the surface, in the atmosphere, there may be regions that are less immediately impossible than the world below. So before we decide whether humans could ever survive near Venus, we have to separate two very different ideas: landing on the surface and living somewhere in the skies above it. Those are two very different ideas on Venus. If we are talking about the surface, the answer is almost brutally simple. With anything close to current human technology, Venus is not a place where people could step outside and survive. It is not a place for footprints, flags, open helmets, or astronauts walking across a dusty plain. The ground exists, but it is buried under heat, pressure, toxic air, and chemical danger. A human body cannot meet that world directly. Not for minutes. Not for seconds. Not at all. The surface of Venus is not like the Moon, where the danger is mostly emptiness and radiation. It is not like Mars, where a person can at least imagine a spacesuit on a cold desert under a thin sky. Venus is different. The surface is a hot, pressurized chamber under a thick atmosphere. To stand there, a human would need a machine around them strong enough to act as a deep ocean vessel, a furnace shield, a chemical barrier, and a complete life support system at the same time. That is not a normal spacesuit. That is a walking survival capsule. And even then, the planet would be fighting it every second. This is why the question, could humans survive on Venus, has to be separated carefully. Survive where? On the surface? In orbit? High in the atmosphere? For how long? In what kind of vehicle? Venus is not one simple environment. It is a planet with layers, and the difference between those layers is enormous. At the bottom, Venus is a nightmare. Higher up, the story becomes stranger. Because while the surface is almost impossible for humans, the upper atmosphere has conditions that are less immediately hostile in some ways. Not safe, not Earth-like in any normal sense, but less impossible than the ground below. This is one of the strangest twists in the Venus story. The most survivable region of the planet may not be on the planet at all, but floating above it. The surface is death. The sky may be the only place where survival can even be imagined. That idea sounds backwards because humans usually think of the ground as safety. On Earth, the ground is where we live. The sky is where we need machines. We build houses on land, walk on surfaces, and think of landing as arrival. But Venus reverses that instinct. The ground is the most hostile place. The higher atmosphere, far above the furnace below, becomes the only region where the idea of human presence starts to feel less impossible. Not easy, not comfortable, not naturally habitable, only less impossible. In the upper atmosphere of Venus, temperatures and pressures can become closer to values that machines and perhaps future habitats could manage more realistically. A floating platform, balloon, or airship-style habitat has been imagined because it would avoid the worst of the surface heat and pressure. Instead of fighting the crushing lower atmosphere from the ground, a mission could remain high above it, suspended in the thick air. Venus is strange enough that floating may be easier than landing. That is one of the most fascinating things about the planet. Its atmosphere is so dense that buoyancy becomes an interesting possibility. A habitat filled with breathable air could, in principle, float in the Venusian atmosphere, because breathable air is lighter than the carbon dioxide atmosphere around it. The very atmosphere that makes the surface deadly could help support a floating structure high above the ground. Venus turns danger into contradiction. The atmosphere kills you below. But higher up, that same thick atmosphere might help hold a habitat aloft. This does not mean Venus becomes a second Earth in the clouds. The problems remain enormous. The atmosphere is still not breathable. The clouds are still chemically hostile. The environment still requires protection. Any human habitat would need to be sealed, controlled, powered, cooled or heated as needed, protected from corrosion and able to survive for long periods without easy rescue. A floating city in the Venusian sky is not a simple idea. It is one of the most difficult engineering dreams in planetary exploration. But it is easier to imagine than walking on the surface. That fact alone says something terrifying about Venus. The ground is so bad that the clouds seem like the better option. If a human mission ever approached Venus seriously, it might first avoid the surface entirely. Orbiters can study from above. Balloons or aerial probes could drift through the atmosphere. Floating laboratories could, in theory, remain high enough to avoid the worst of the heat and pressure. Instead of descending all the way into the furnace, humans might stay in the layer where Venus is still dangerous, but not instantly impossible. It would be exploration without landing, a mission to a planet where touching the ground is the mistake. This changes the meaning of arrival. On Earth, arriving means coming down to the surface. On Mars, the dream is boots on the ground. On the Moon, the historic moment was human feet touching lunar dust. But on Venus, the heroic image might not be a footprint. It might be a floating station drifting above an unlivable world, looking down at clouds that hide a furnace. The best way to survive Venus may be to never land. That connects directly to the title. Venus would kill you before you even land, because the descent itself becomes lethal. But if humans ever survive near Venus, they may do it by refusing the descent. They may stop above the worst layers. They may live in the sky because the surface is too hostile to touch. That is not victory over Venus. It is negotiation with the least deadly part of the planet. Even then, the danger would remain everywhere. The outside atmosphere could not be breathed. The clouds could damage materials. A failure in the habitat would be catastrophic. There would be no open environment to retreat into, no natural water, no trees, no rivers, no soil for ordinary life. Every moment would depend on the structure working perfectly. Survival would mean carrying Earth with you. Air, pressure, temperature, water, power, food, protection, communication. Without those systems, Venus gives nothing back. This is true for all human space exploration, but Venus makes it more extreme. On the Moon, the danger is emptiness. On Mars, the danger is thin, cold air. In deep space, the danger is vacuum and radiation. On Venus, the danger is an active planetary environment pressing in around you. It is not a missing atmosphere. It is too much of the wrong atmosphere that makes every habitat feel fragile. No matter how advanced the technology becomes, a Venus mission would always be a fight against the planet's natural state. The goal would not be to live with the environment the way life on Earth does. It would be to keep the environment out. The barrier between life and death would be a wall, a seal, a filter, a cooling system, a pressure system, a chemical shield. Venus would always be outside, and outside would always be fatal. This is why surface colonization is so difficult to imagine. A colony on Mars is already a huge challenge, but at least the surface is cold, solid, and relatively accessible compared with Venus. A habitat can sit on the ground without being cooked by lead melting heat. Rovers can move. Solar panels can work when dust allows. People can imagine domes, underground shelters, and pressurized vehicles. On Venus's surface, every one of those ideas becomes far harder. A dome would have to resist crushing pressure and intense heat. Vehicles would have to operate in a furnace. Power systems would have to survive temperatures that destroy electronics. Repairs outside would be almost impossible. Even the simple act of opening a hatch would be deadly if anything went wrong. The planet does not offer normal engineering problems. It offers stacked survival problems. That is why the more realistic human future around Venus may be orbital or atmospheric, not surface-based. Orbit avoids the atmosphere but stays far from the ground. The upper atmosphere avoids the worst surface conditions but still requires extreme protection. The surface offers science, but it is the most punishing place to remain. Each option is a compromise. Orbit is safer, but distant. The clouds are closer, but dangerous. The surface is direct, but brutal. A human mission would have to choose what kind of risk is worth taking. And for a long time, the surface may simply be too much. Venus is one of those worlds, because it forces us to ask what habitability really means. Is a planet habitable because it is rocky? No. Because it is close to Earth's size? No. Because it has clouds? No. Because it has an atmosphere? Not necessarily. Venus has all the wrong answers to those simple questions. It shows that the details of a planet's atmosphere and climate decide everything. That is why humans may study Venus from above long before they ever try to stand below. The sky could become a laboratory. The surface could remain a target for robots. And the planet as a whole could become one of the best warnings in the solar system. If humans ever floated in the upper atmosphere of Venus, the psychological experience would be unlike anything else. They might look out at a thick cloud world beneath them, knowing that below those clouds is a surface no person can touch. They would be close to a planet, inside its atmosphere, but separated from its ground by layers of death. It would be like living above a world that refuses to become home. The view might be beautiful. The knowledge would be terrifying. This is why the phrase, "Could humans survive there?" cannot be answered with a simple yes or no. On the surface, not in any ordinary sense, and not with current practical mission concepts. In the clouds, perhaps. One day, with enormous engineering and constant protection. In orbit, yes, in the same basic way humans can survive in spacecraft around other worlds. But living naturally on Venus, the way we live on Earth, is not part of the planet's reality. Venus does not offer nature to humans. It only offers environments that technology must fight. That makes it different from science fiction dreams of easy colonization. There are no forests under the clouds, no seas to sail, no open air, no landscape waiting for settlers. The old Venus fantasy died because the real planet is not a hidden paradise. It is a hostile world where any human presence would be artificial, temporary, and dependent on engineering. A human could only survive Venus by not truly touching it. That may be the most honest answer. If you stay above the surface, protected inside a machine, maybe survival becomes imaginable. If you try to land like Venus is another Earth, the planet wins. That is why Venus is so different from Mars in the human imagination. Mars is hard, cold, dry, and dangerous, but it still looks like a place. Venus looks like a planet from orbit, but its surface behaves more like an environment humans should avoid completely. Mars says, perhaps one day, with enough work. Venus says, not here. Not like this. Venus is not a frontier in the usual sense. It is a boundary, a limit, a reminder that not every rocky world is meant to be walked on. It is what makes Venus valuable as a warning, because Venus shows that a planet can be almost the right size, almost the right kind, almost familiar from far away, and still become completely wrong for life as we know it. It shows that atmosphere can decide destiny. It shows that clouds can hide disaster. It shows that habitability is not guaranteed by being a rocky world near a star. Venus is Earth's dark mirror. And that is where the final chapter must go. Not only into how Venus would kill you, but into what Venus says about Earth. Because the most disturbing thing about Venus is not just that it is deadly. It is that it is close, it is bright, it is rocky, it is almost our size. And it reminds us that a world can begin with familiar ingredients, and still become a warning written in heat, pressure, and clouds. That is the final meaning of Venus. It is not only a planet that would kill you before you landed. It is not only a furnace wrapped in acid clouds. It is not only a place where machines die quickly and humans could never touch the surface without extreme protection. Venus is more disturbing than that because it stands beside Earth as a reminder that rocky planets do not all become homes. Some become warnings. From far away, Venus and Earth belong to the same family. Both are rocky worlds. Both formed in the inner solar system. Both orbit the same sun. Both are large enough to hold atmospheres and shape their own planetary histories. If you only looked at the simplest facts, Venus might seem like Earth's sister. But the closer we look, the more that sister becomes a dark mirror. Earth has blue oceans. Venus has hidden rock beneath toxic clouds. Earth has breathable air. Venus has a crushing carbon dioxide atmosphere. Earth has rain that feeds rivers and life. Venus has clouds linked to acid and a surface too hot for ordinary machines. Earth became open, living, and temperate enough for us to ask questions about the universe. Venus became sealed, overheated, and almost unreachable. That contrast is the reason Venus matters so much. It shows that habitability is not guaranteed by size alone. A planet can be almost Earth-sized and still be nothing like Earth in the ways that matter. It can be close, bright, beautiful, and rocky, while still becoming completely hostile to life as we know it. Venus looks familiar at first. Then, it teaches us not to trust familiarity. This is the deeper answer to the title. Venus would kill you before you even land, because the planet is not simply dangerous at the surface. Its entire environment is wrong for humans. The clouds hide and threaten. The atmosphere thickens and presses. The pressure becomes crushing. The heat becomes unbearable. Even before touchdown, a descent would already pass through layers that reject biology and challenge machines. The ground is only the final place where the planet finishes what the atmosphere began. A human landing would not be a heroic step onto another Earth. It would be an attempt to enter a world that has already declared the body impossible. There is no breathable layer waiting near the surface, no cool valley, no ocean hidden under the clouds, no open place where an astronaut could stand and look around as if on Mars or the Moon. Venus gives you a surface, but it buries that surface under conditions that make the surface almost meaningless for human exploration. It is a rocky world, but not a walkable world. That difference is important. We often imagine planets as destinations. A spacecraft arrives, a lander descends, a hatch opens, a person steps out. But Venus breaks that story. It tells us that having a surface is not enough. A surface can exist and still be unreachable. A surface can be mapped and still be deadly. A surface can receive a machine and still destroy it shortly afterward. Venus offers ground without welcome. That is what makes it so haunting. The planet does not need to be mysterious anymore, to be terrifying. We know enough to understand the danger. We know the surface is extremely hot. We know the pressure is crushing. We know the clouds and atmosphere are hostile. We know robotic landers survived only temporarily. The old mystery of what is under the clouds has been replaced by a darker certainty. What is under the clouds is not a second Earth. It is the answer to what a rocky planet can become when its atmosphere and climate go in the wrong direction. This is why Venus is often described as a warning, but the warning should be understood carefully. It is not a simple message that Earth will suddenly become Venus. Earth and Venus have different histories, different conditions, and different details. But Venus proves that planetary climates can be powerful enough to define the fate of a world. It proves that an atmosphere is not just a thin, decorative layer above rock. An atmosphere can save a planet, or it can trap it. On Earth, The atmosphere makes life possible. It holds pressure, carries oxygen, moves water, softens temperature extremes, and protects the surface in many ways. But Venus shows the other side of atmospheric power. A dense atmosphere dominated by heat-trapping gas can turn a planet into a sealed furnace. Clouds can hide the ground. Pressure can become ocean-like. Heat can become permanent. The same idea, atmosphere, becomes two completely different realities. On Earth, sky means life. On Venus, sky means death. That is a terrifying comparison because the word sky feels gentle to us. It is where birds fly, where clouds drift, where rain begins, where sunsets glow. But on Venus, the sky is not a place of openness. It is a lid, a heavy, toxic, heat-trapping lid that presses the world beneath it into one of the most hostile surfaces in the solar system. The surface of Venus is not just hot. It is trapped under its own air. That makes Venus feel almost like a planet buried alive. The ground exists below, but it is hidden, sealed, and punished by the atmosphere above it. The clouds make the planet beautiful from the outside, while making the truth harder to see. The atmosphere gives Venus a bright face and a deadly heart. This is why the beauty of Venus is so unsettling. It is real beauty, but it is not kindness. The planet shines in our sky because sunlight reflects from its clouds. It can look calm, steady, and elegant. It can appear in the morning or evening, like a small white flame. Ancient people watched it. Modern people still see it. It is one of the easiest planets to notice with the naked eye. But that bright point is the top of a nightmare. The distance makes it gentle. The descent makes it honest. And honesty on Venus is brutal. If you followed the journey from orbit downward, the planet would slowly remove every illusion. At first, it is a shining sphere. Then it becomes a cloud-covered wall. Then it becomes an acid sky. Then the atmosphere thickens. Then pressure rises. Then heat becomes impossible. Then the surface appears not as a destination, but as the bottom of a trap. That is the structure of Venus. Not one danger, a descent through many dangers. Venus does not ruin our curiosity. It deepens it. Because now the question is not only how to land there, the question is why it became this way. What happened to its early water, if it had much? How did its atmosphere evolve? What role did sunlight, volcanic activity, chemistry, and planetary history play? How did two rocky planets near each other become so different? Venus is not just a destination. It is a planetary crime scene. The victim is habitability. The clues are in the atmosphere, the rocks, the clouds, and the heat. This is why future missions to Venus matter, even if humans never walk there. Orbiters can study the atmosphere and surface from above. Radar can map the hidden terrain. Atmospheric probes can sample the clouds. Landers can try to survive longer and send more data. Every mission helps us understand not only Venus, but rocky planets in general. To understand Earth, we need to understand what Earth avoided. Venus is one of the best examples of what Earth is not. That makes Earth feel more fragile in a cosmic sense. We live on a planet where the pressure is gentle, the air is breathable, the oceans are liquid, and the temperature allows life. These things feel normal because we were born here. But Venus reminds us that normal is local. Earth's comfort is not automatic. It is the result of a long planetary history that could have gone differently. Earth is not safe because rocky planets are always safe. Earth is safe because this particular world found a balance. Venus did not. That difference is the dark warning. Not that Venus is evil. Not that the planet chose destruction. But that planets are physical systems, and physical systems can move toward outcomes that are deadly for life. There is no guarantee that a world with clouds, rock, sunlight, and atmosphere will become habitable. Those ingredients can produce oceans, or they can produce a furnace. They can support life, or they can erase the possibility of standing on the ground. Venus proves that the same solar system can contain both a garden and an oven. Earth and Venus are close enough to make the comparison uncomfortable. One is home, one is a warning next door. This is why the final feeling of the video should not be only fear. It should also be appreciation. The more we understand Venus, the more extraordinary Earth becomes. A breathable atmosphere is not boring. Liquid water is not ordinary. A mild surface pressure is not guaranteed. A climate that does not melt metal is not something to ignore. The simple act of standing outside under a blue sky becomes more meaningful when we remember what the sky could have been. On Earth, the atmosphere touches your skin gently. On Venus, the atmosphere would crush and burn. On Earth, clouds bring shade and rain. On Venus, clouds hide a lethal world. On Earth, the surface is where life grows. On Venus, the surface is where machines die. The comparison turns home into a miracle without needing to exaggerate. Earth is not perfect. It is not immune to change. It is not separate from planetary physics. But it is habitable, and Venus shows how rare and delicate that state can feel when placed beside another rocky planet that lost the path. This is why Venus is more than a space horror story. It is a lesson about conditions. The universe is full of worlds, but not every world is a home. Some are too cold, some have no air, some have no surface, some are torn by radiation, some are buried under ice, and some, like Venus, are so close to the idea of Earth that their failure feels personal. Venus is terrifying because it almost belongs to our category, but almost is not enough. Almost Earth-sized, almost familiar, almost tempting, but not survivable. That is the final warning in the word almost. In planetary science, almost can be the distance between oceans and fire, between breathable air and toxic pressure, between a world that grows life and a world that kills machines. Venus teaches that details do not come after habitability. Details are habitability. The pressure matters. The chemistry matters. The heat matters. The history matters. A planet is not one number. It is a whole story. And Venus's story is one of the darkest in the solar system. It began as a bright point in our sky, became a dream of hidden oceans, then turned into the most powerful example of a false twin we have ever found. It forced us to abandon the easy idea that nearby rocky worlds might naturally become Earth-like. It showed us that a planet can hide its surface, trap its heat, and become a place where survival is almost impossible. And still, it remains beautiful. That is the last contradiction. Venus is beautiful and deadly, close and unreachable, Earth-like and completely alien. A planet with a surface that almost no machine can endure for long. A world that shines like a promise and behaves like a warning. So, if you ever see Venus in the evening sky, it may look peaceful. It may shine brighter than any star around it. It may seem calm, clean, and almost gentle. But behind that light is a world where the clouds are hostile, the air is crushing, the heat is constant, and the surface is a furnace. A world where a human would never step outside. A world where even robots speak briefly, then fall silent. A world that shows us what can happen when a rocky planet becomes trapped by its own atmosphere. Venus is not Earth's twin in the way people once hoped. It is Earth's dark warning. And that is why anyone trying to land there would not be walking into a second home. They would be descending into a planet that begins killing long before the ground arrives. Thank you for watching this journey into the deadly world hidden beneath the clouds of Venus. If you enjoyed this calm exploration of one of the most hostile planets in the solar system, Subscribe to the channel for more space documentaries like this. Leave a like if you want more deep journeys into dangerous worlds, and write in the comments what impossible space mystery you want to explore next. Tonight, you are watching the Just About Space channel, talking about why Venus would kill you before you even land. Sleep well, and keep looking up. Good night.